So welcome to AI on Demand, AutoML in Operations. My name is Heleen Snelting. I am the Director of Data Science for TIBCO. I have a background in CPG and retail analytics and have been with TIBCO for 5 years. And I'm here with my colleague Ian Pestell.
Good afternoon everybody, my name is Ian Pestell, Senior Data Scientist here at TIBCO. I've been with...
So there's some audio issues?
My name is Ian Pestell, Senior Data Scientist here at TIBCO. Been TIBCO 2 years. My background can be summed up as all things data.
Okay. Thank you, Ian. All right, so first a disclaimer. Anything that we share with you today is for informational purposes only. The agenda for the next half hour is I'll introduce TIBCO a little bit more and the broader context of data science. And then we'll dive into AutoML, auto machine learning. We'll also give a detailed demo of auto machine learning. And we'll discuss a few next steps in how you can get involved and learn more. A question that I often get about AutoML is whether it's going to replace the data scientist. If you're concerned about that or happy about that, I guess. But the answer is no. AutoML is not going to replace data scientists, but it's certainly going to make the job of a data scientist a little bit easier. And by the end of the presentation, hopefully you'll understand why. So a bit more about TIBCO. TIBCO is a global software organization. We are headquartered in Palo Alto in the US. Our headquarter for Europe is here in London. We have about 10,000 organizations worldwide using our software. And we have what we refer to a TIBCO Connected Intelligence Platform. And this is a platform that has software that has capabilities to connect all your data, all your devices, anywhere where your data lives. It also allows you to unify all that data to create one single version of the truth, data that can be trusted, that then can be used in your analytic applications, which we refer to as augment. So data science, data visualization, streaming data, which is really what we'll be focusing on in the presentation today. And there are three key foundations for TIBCO that we build our platform on and that we develop our capabilities towards. And that is, first of all, that it needs to be cloud native. Secondly, that it's a very open platform so that it allows for you to use, all kinds of data and technologies, including open source. And thirdly, what's very important is that AI is a foundation of the platform. So what we do as TIBCO is we build AI engines to save you time and to automate certain steps in all the steps that you take to build digital business solutions. And auto machine learning, AutoML that we'll talk about today, is one example of these AI engines. So the initiative that we use to build AutoML is called TIBCO Labs, and it's actually a place where we invite customers to innovate with us. So that's TIBCO Labs, and that's where AutoML was built. So AI success stories. There are a lot of success stories that we can talk about. Anomaly detection, recommender systems, forecasting demand across all the industries. And it's important to us to message you, to make sure that you understand that the real value of data science is not by creating a perfect model, but it's by accessing the data and the intelligence and creating a very good model, but putting that into a live production environment. So that's what we focus on a lot at TIBCO, and the TIBCO data science team has built a number of assets for you in our public community to give you a bit of a fast start to build some of these applications yourself. We have examples of customer work that we've done across industries, across different use cases, and hopefully some of these will apply to the job that you're doing on a daily basis. And so we've got downloadable templates, videos, tips and tricks available for you to use to get started with AI on demand or AI in operations. And we work on these projects with customers, and we see a lot of success when they apply these applications. The success that we see can be in improved profitability, sometimes double-digit improvements in profitability, improvements in customer satisfaction, which often is measured by NPS scores, and ultimately that really generates a competitive differentiation that's very important today. So one of the examples I want to dive into a little bit more detail is the dynamic pricing that we developed together actually with an insurance company, AA Ireland. They're a public reference for us, so I can mention them. They support us in the developing of the more generic assets as well that are available for all of you to use. And the reason why I wanted to explain this example is because it I think also tells you how AI is developing and how data science applications need to be developed in terms of deploying it in operations. So first of all, when you look at the platform that TIBCO provides, there are a lot of options to combine different data sets. So for this real-time pricing application, we needed a lot of different data sets coming from the web, coming from entries, from customers requesting a quote for insurance, historic data, some regulatory type of data. So once all that data is assembled and understood, you can build the model, the data science model that can be used, using different flavors, I guess, depending on the preference of the data scientist. Once the model is developed, trained, tested, it can be accepted by the organization and then deployed in real time. So for the insurance company, in this case, it was when people are submitting a quote request online, they get the price that is optimal for this customer, considering all kinds of aspects that they need to consider when submitting the optimal price for each customer. So then, once the price is submitted, over time, the insurance company can monitor the price and the acceptance rates of these submissions of the price. So some get accepted, some don't, and you can set thresholds for this acceptance rate. And the data from these acceptance rates get fed back into the system to improve the model over time. So you can rebase the model on a weekly basis or monthly basis, depending on how quickly sort of your internal and external circumstances change. You can also update it instantly if you cross a certain threshold. So if all of a sudden the acceptance rates are really high or really low, that's probably an indication that something significant has changed. So you can automate a review of the model for that reason as well. So as you can understand, because of this, because we refer to this as continuous learning, continuous optimization of your data science models. And you can imagine that a lot of different teams are involved in doing this because there are different steps and different teams with different expertise levels that are involved in this, in building these applications, but also maintaining them. So you have the data engineers, the data scientists, citizen data scientists, more of the IT and developer type profile, and then very importantly the business people who will be initially developing the question that needs to be answered or the problem that needs to be solved, but also who will be reviewing the results and providing input to further improve the models. So this is, for us at TIBCO, it's really important that we build software that allows these teams to collaborate. The handoffs are extremely important, and if you get it right, then you can really speed up the deployment cycles of these, building these applications, which is the type of benefit that we see when customers are using our tools. So another aspect that we take into consideration at TIBCO is, and I've actually seen a number of presentations today about responsible AI. We had a meetup a few weeks ago about this topic as well, or where this topic was discussed. Because AI can be used for good, but it can also, it causes a lot of questions and sometimes concerns in organizations. And increasingly, the people that we just mentioned, the different teams, they need to explain what they're doing and why they're changing models and why they're updating to a new version. This example from Bank of America, for example, it's the head of global business solutions who was asked, what is responsible AI for you? And they were responding with, we have a type of paranoia production system in place, because every time we question what we're doing with AI, and if it doesn't feel right, or if we can't explain everything 100%, we're not doing it. And obviously they handle a lot of sensitive data. Similarly, with facial recognition, it's very easy to build a facial recognition application these days, but you need to make sure that you're using it for the right causes. So in this example, it's used in the US for preventing crime in schools. We've seen examples at the Spotfire meetup recently where we talked about the use of facial recognition in China, where it gets used to to look at attendance, but also sort of how alert the students are in the class. So sometimes you may question if it's the right usage of image recognition. So keep asking those questions. But the reason why I brought up that example, because it inspired the project goals for AutoML, Auto Machine Learning, which is an automation effort as part of the AI engine that I mentioned earlier. So transparency is really important in how we developed AutoML, so that you can understand what's happening. Also explainability. And scalability, that's much more, I guess, related to the TIBCO tooling itself, that is very scalable and focused on in-database machine learning. And also we found it very important to have it be extensible. Because of the wider TIBCO platform, once you've created the model, it needs to be very easy to deploy in any of the other applications that you want to use it in. So I think most of you know what machine learning is, but just to put this in the context of AI, so machine learning is just a very popular branch of AI. It involves a lot of different steps: data preparation and cleansing, feature engineering, feature selection, model training and scoring and selection. And all of these steps are quite complex for machine learning, and they get increasingly complex with the sort of plethora of algorithms that are available and the choices that you can make in the development of a machine learning process. So AutoML is really developed to help automate some of those processes and reduce the time spent by data scientists on developing those. So the benefits are for data scientists that the work gets done much more quickly. It also allows data scientists to develop more options, so they get to a better, best model in the end. And it also increases the ability for citizen data scientists to get involved in the data science process and contribute to the application building process. And it gives a lot of guidance and understanding of why certain workflows are used. So I think this is a good time to demo this AutoML to you, and Ian will take over from here.
Okay, thank you, Heleen. So the platform that we've developed the AutoML in is actually the TIBCO data science platform. This is actually a collaborative platform for data scientists, either true data scientists or citizen data scientists. It has a number of aspects to it. The first is the ability to connect to a wide variety of different data sources, and they can either be SQL sources or no SQL sources. And the important thing about this actual product is that we try and push the computation down to the underlying data sources so that we can handle very, very large data sets at scale. The tool is collaborative, so there can be multiple people working on the tool at any one point in time. And essentially, to process the data, we then, through the workspaces, create a set of workflows. So I've got a set of workflows here associated for the AutoML, which contains a series of work files. The first thing I'll do is actually just go through the kind of process that we need to do manually. So this is a workflow, and what we're actually doing here is looking at processing fraudulent transactions for an insurance company. So we have information, a data set from one of those data sources, which is the customer information, being joined with the actual transactions that are being made, and there is a flag on these particular items, whether the transaction was fraudulent or not. And then we're combining that with potentially income data, and it's being combined with by a zip code. Now, there's a number of processes we then have to go through that with that data. There's a certain amount of data cleansing, data preparation that we need to do, and you can see here that we're rejoining the data, we're reclassifying the buckets in this case, we're taking out null values for some of the categorical variables, and we're normalizing the non-categorical variables. Then typically, the next thing we'll do is split out a couple of data sets, one for training and a holdout data set for testing, and then feeding those into the various different models. In this case, it's a binary classification problem, so the models that I'm selecting are there for binary classification. We have another node here which is then assessing the quality of those nodes. If I click on here, we can see the output, and we can see the actual, for example, heat map of the true and false predictions, that this actual model is making. Sorry, see to scroll down there. Now the thing is about this is, this has had to be put together manually. It requires some expertise to understand, which models to use, what to do with the data, and more importantly, if I want to run this over and over again and try different hyperparameters for each of these models, I'd have to run multiple iterations of this model. So the whole idea of the AutoML process is to take a lot of the work out of this process and to get you to a point of this kind of very similar workflow with less effort. So if I actually look at the same flow using AutoML, you can see that we actually start off with a very similar process in that we're combining together the three data sets in question. But now, rather than having that complex flow, we introduce a new node here. One thing about the data science platform is we have the ability, through a set of open APIs written in Scala, to extend the platform through a thing called custom operators. So we can actually build our own nodes here, and we can drop them onto the palette in the same way as we would do the nodes that come with the product. So we've built an extension to the product for this AutoML process, and this kind of robot icon here is one of those processes. So what's going to happen now is, by setting up this workflow, we can run that workflow. That workflow can take several minutes to run because obviously it's running several iterations of models. But again, we can see the output of this by clicking on this node here, and we can see there is this model leaderboard which actually shows us the different models that it's attempted to run with the different strategies, which I'll go into later, and with different hyperparameters. And these are ranked in their order of accuracy. So you can see that our most accurate model is strategy 1 using a gradient boosted tree. Now, the important thing about this, by the way, if I click on any of these nodes, we can configure and alter the actual execution of that flow. For example, I can say what users are executing it, but there is a parameter here which actually indicates whether you want to go shallow or deep. So whether we want to go across a wide number of models very quickly, or we want to drill down into a particular type of models for more accuracy. Now, some products that do AutoML is a complete black box. You run the AutoML and you see the results. We've taken a very different approach. When you run that node, what it's actually going to do is generate for you a whole series of different workflows. There's two reasons for this. The first is that we can actually see what's going on. We can explain exactly the process that's gone on here, but also you've got the ability to modify and extend those workflows yourself. So for the data scientist who wants to go deeper, change the model parameters, rebase the models, you've got the ability to do so. It's created a framework, a starting point for you. So running this node will create a number of additional workflows. Again, if I just show you these workflows, the first of which is a data preparation workflow. And you can see here what it's done is it's taken that data set that we prepared by joining the three tables. It's now gone through some data cleaning, taking out variables, for example, a non-variable. They're not going to contribute anything to this. We are making sure that the labeled outcome we have no null values, again taking those out. And also that we are, making a high and low value for this. Again, it's done the split of the training set and the test set, ready for analysis. So the next stage that the AutoML will generate is the feature engineering process. And what it's going to do is it's going to take both of those training sets and it's going to, again, do a little bit more data cleansing on this, so looking at the significant variables, filtering those out, replacing any nulls for the target variable, normalizing the normalizing any numerical values in here. The two strategies I mentioned earlier, we're going to try different strategies. First of all, to identify which are the significant variables. So obviously the input variables going into this model, some are going to have an impact, some are not. So we want to be able to assess which of the variables are more important for this analysis. And there's two strategies you're using here. The first one is a weight of evidence strategy, and the second one is an impact encoding strategy. Now these are common strategies. If you want to go and look up what these are, you can find them. They're common techniques for understanding the sensitivity of variables. So once that feature engineering process is done, the next workflow here is actually then doing the feature selection. So each of the features based on that last process will be ranked. We're going to take the significant ones out and we're going to generate a set of models using those significant variables that we've established. So the last stage in here in terms of the model generation is to actually create the actual models itself. And you can see in this workflow what we're actually doing is taking the output of those two strategies and feeding them into different types of models. As I mentioned, this is a binary classification problem, so in this case we're selecting random forest, a gradient boost and a linear regression models here. And this is run for both of the strategies, and the output here is a goodness to fit curve, which kind of gives us the model I showed you earlier, the output, the matrix showing you which is the good and bad models. Now, the fact that we are actually generating a new workflow here means that I can see what's going on, but also I can change this. So, for example, fraud data tends to be very infrequent in a set of transactions, so often it's very skewed. So one thing you may want to do is rebalance that data. So what I can do here is I can actually now modify this flow. I can actually take and add additional node, which is the resampling. I can just reconnect it to the other two nodes. And I can configure this resampling. So the important thing here is that you can modify the actual workflows that are generated. It's not a complete black box for you. It's the starting point at which you can now take further, and you can now rerun this part of the analysis, which may yield better results. The other thing about all of this is, as I mentioned earlier, is explainability. So in the decision-making process about what variables we're using here and which ones are significant, we're actually again generating another workflow, which is explainability, which actually has the various processes that we've gone through to establish, for example, which models to use, which input parameters to establish. And you'll notice here that it's exporting some of this information as SBDF files. Now, SBDF files is a format which we can feed into our reporting tool, which is TIBCO Spotfire. So in Spotfire here we have a dashboard which is showing us an insight into that explanation and analysis. So here you can see all the different input variables that were in that data set, and here is the output of the sensitivity analysis that we did on those input variables. So you can see here that we are reckoning that income is actually quite a significant factor in actually assessing the accuracy of the model. So if I drill down into that deeper, you can see down here further breakdown. We're actually showing you, the significant parameters, but also a breakdown of the buckets. And you can see these two lower income sets are contributing quite a lot to the accuracy of the model. This one here is a single data point, so it's probably an outlier. We could remove that and again rerun the models if we wanted to do so. So you can see here what the AutoML process is allowed us to do is to start off with the data set, to generate a set of workflows for both data preparation, feature engineering, which you can use as a starting point for further analysis and further refinement, and also a detailed explanation of how the engine itself is coming and establishing those results. Okay, Heleen.
All right. So thank you very much for that demo, Ian. We saw the different steps from AutoML and how it creates all these workflows for you automatically. I wanted to ask you actually, Ian, when you first started to use AutoML, what were the main benefits for you when you first saw it?
Yeah, sure. I mean, I think there's two main aspects to it. The first is that saving in time. Mm-hmm. A lot of the time you're going through a process, and it's a process that is almost semi-automatic in your own mind. You go through a certain set of steps. So it's actually taking you there, which has an advantage in saving time, but also in accuracy. You can be sure that the decisions that are being made are going to yield you good results. But the second aspect of it, the fact that you can see what the AutoML process has done and it gives you a starting point for further analysis, I think is very valuable. It's a white box approach rather than a black box approach.
I saw you were editing the workflow, so that's pretty easy to do.
Indeed,
yes.
Indeed.
Okay. And I guess in terms of best practices, I was reading in one of the operators that the best practice of an 80-20 division of rows in terms of data for training versus testing is applied.
Yes, for the whole outset.
So that would be helpful for a citizen data scientist.
Exactly. Yeah. So in this whole algorithm that's being used to establish these workflows is a set of best practices, a set of expertise that we've established over the years that we managed to encapsulate and incorporate into that process. So what that means is that expertise is now instantly available to the citizen data scientists, someone who's less experienced, but also, again, to the experienced data scientists, still cutting down on time and making sure that the model is used appropriately.
So getting a bit more of the whole team working on the data or science applications. Okay. And maybe lastly, the in-database at scale I guess aspect of this is not specific to AutoML, but specific to the data science tool.
Indeed. Yes.
Can you talk a little bit about the architecture?
Yes. So underlying this platform is actually based on Spark. And what it will actually do is it will actually push down all the machine learning operators that you're seeing here in the workflows to the underlying data platform, whether that be a relational database or whether it be the Hadoop platform. So it means that you're actually taking the compute to the data. Mm-hmm. So the data is sitting there. It can be very, very large data sets, and we can exploit the power of large clusters in Hadoop and in Spark to actually process and very large data sets with speed, leveraging the power of MPP. So this is a very, very, very scalable solution. Mm-hmm. And because we're using the same framework for the AutoML is exploiting that same power of the underlying architecture.
Thank you for explaining that. So that also is why this is, an application that is very useful now because of the data sets continuing to get bigger and bigger. So I think also looking at the time, I wanted to make sure that everyone knows that we have a lot of this written up and available for you to get involved in. We have videos, we've got blogs, so depending on sort of the level of detail that you'd like to learn more about AutoML, those are available. We'll be sharing the slides with you as well. I think they'll be available on the Big Data London website. We'll also have some webinars available for you to review this. The other thing is that the data science team in general tries to communicate with all of you as much as possible to share these type of insights. So we have a community where we publish blogs. So every time we come up with something interesting that we think is interesting for you, you can read those blogs on the TIBCO community site. We're also holding virtual meetups to share this type of knowledge. So the next one is actually next week on the 20th of November. You can sign up for this meetup series, and then every few months you'll be invited for a virtual meetup to get an update on the TIBCO technology. Last but not least, you can join us at the TIBCO booth on booth 467. It's near the Mercedes Formula One simulator. And especially for our Data for Good initiative, hopefully you heard about this at the keynote yesterday. TIBCO is also driving an initiative to try to reduce the number of homeless people on the street in London and the UK in general with some of our partners. And we would like to invite everyone to get involved in that initiative. So if you hold your phone up and you take a picture of this, you'll get a registration form to show that you're interested in participating. And we'll be able to provide you with some more information. So thank you very much for your time, and we're happy to take any questions now or at the stand.